Dear students, today I am going to show you the nickel resistivity experimental setup. For that we need to have a current source which is given here. Basically we are measuring the resistivity of nickel as a function of temperature using 4-probe method. Okay, so we have a current source through which we can pass the current, and then this current is passed through using a DP/dt switch, and this switch, as I discussed in the last class, has a toggle switch. By changing this, you can change the polarity of the current. Okay, so you can change from positive current to negative current by changing the polarity of the toggle switch. And also we have in this DP/dt switch a constant 1 ohm resistor is connected, which is in series with respect to the sample. So if we measure the voltage across this, okay, which is given by the which basically gives you the current flowing through the sample. Okay, so this we are measuring outside, because when the sample is heated, the impedance or the resistance will change and the voltage drop will change. So we cannot rely on the voltage across the sample. We have to measure the voltage across the constant resistor which is kept outside to measure the quantity of current passing through the sample. So, okay, so this is basically VR, and when we measure by changing the current, we can get VR plus and VR minus. Okay, and then we have here this is to measure the voltage across the sample. Okay, so this, if we know the voltage across the sample and you know what is the current that you are passing through the sample, then you can measure the resistance of the sample at any given temperature. So the experiment is very simple, in the sense you just pass a current and then measure the voltage across the sample. By knowing the voltage across the constant resistor, you can know the amount of current passing through the sample, and you can determine what is the resistance of a given sample. So the experiment involves the temperature dependence, variation of the resistance as a function of temperature. Okay, so before that I would like to show you the sample holder. So we use here pressure contacts, basically spring loaded pressure contacts, and the sample is with a nickel strip which is mounted here between these two strips, and then there are 4 probes. Okay, so the inner probes we will connect to the voltage probes to measure the voltage across the sample, and the outer probes are connected to the current source. So in all we have 4 probes to pass or apply the voltage and measure or pass the current and measure the voltage across the sample, which will help us to determine the resistance of the given sample. And then to heat the sample, basically sample is mounted at the end of this probe. This is basically the sample rod, I can say, which goes into a double-walled jacket through which we can create vacuum, because it is important to create the vacuum so to maintain the constant temperature of the sample. In this experiment we are heating the sample from 300 Kelvin to all the way up to 700 Kelvin. So to do that effectively, we need to cut down the radiation and convection and conduction to the surroundings. So for that what we do is we will actually use a double wall jacket, and in this is evacuated using a rotary pump. So we connect to the rotary pump and then we evacuate the sample chamber so that the conduction and convection currents are minimized. Okay, and then also to avoid overheating, we'll connect a water pipe to this to the sample chamber, so that to the double walled chamber, so that the process of radiation is also minimized. So water cools through this, and then the heat loss to the surroundings is minimized. Okay, and then how do we change the temperature? To change the temperature, what we need is we need a heater. So this basically is a cylindrical heater. Well, we have a cylindrical tube on which we wind a Canthal wire, which is or nichrome wire, which is a high resistive material. Okay, through using that we can by connecting this heater to a power supply through a temperature controller. So we have a temperature controller and thermistor in this, which will be able to control the heat to the heater or current to the heater, and through Joule heating you can heat this. You can in fact use this to produce the heat, and which will be enable to the sample to get heated. Okay, so You may see that this heater is wound as a coil. So whenever you have a coil and a current passing through the coil, you know that there is a magnetic field associated with that. But in our experiment, we do not want any magnetic field. So we would like to measure this in the zero field. So for that, what we do is, we use a trick called non-inductive winding. So what we do is, we take the wire and then sort of bending into, make it into two halves. Like for example, this is my heater wire. I bend it into two halves and then I start winding this on the coil, so that you see that in one turn the coil is going in a clockwise direction, in another turn the current is going in the anti-clockwise direction, so that whatever field is generated in the clockwise direction gets cancelled by the anti-clockwise direction current, so that the sample doesn't experience any magnetic field. Okay, so through this principle we can heat the sample in the zero magnetic field. Okay, of course S magnetic field is there, which we sort of neglect it for all practical purposes. Okay, so we can set the temperature using this. We can set the temperature to the required amount by increasing or decreasing the temperature. So I can actually set the temperature, and once I set the temperature, then I can one second, stop it. To measure the resistivity at room temperature, what you need to do is, you just have to pass a current and then measure the voltage across the sample. And since you know already the current passing through the sample, you can determine the resistance. And to do the temperature variation, we need to heat the sample. For that, as I told you earlier, we use this heater. And to pass the current through this and also to control the temperature, we use a temperature controller. And using this set point, we can set the temperature, and the sample temperature can be read from here. So once you increase the temperature controller will make sure that the current flows through the sample if the set point is, sample point temperature is less than the set point, and then the sample starts heating. And once the set point reaches, the sample temperature reaches the set point, then there will not be any more flow of current through the heater, and then the temperature will stabilize. So to do the experiment, initially we have to set the temperature to start from 300 in steps of let's say 5 degrees centigrade, and then we have to measure each and every temperature. After stabilizing the temperature, we have to do the same process. Basically, measure the resistance across the sample, resistance across the constant resistor, and the voltage across the constant resistor as well as the voltage across the sample, in order to determine the resistance at a given temperature. Okay, so you do this process up to say 700 Kelvin. Okay, then we'll follow the analysis that I'll be discussing in the class. Okay, thank you.